guys, I hope you enjoyed your guys' spring break and recharged a little, de-stressed a little, and I hope you're ready to go for this week of online learning. Hopefully it will be the only week. Today we are going to look at how to graph a square root function. So before we dive into that, I have just a little warm-up. I'm going to bring you back to first quarter. And we are going to graph this absolute value function. So just kind of a quick reminder, here was our kind of basic form for an absolute value equation. And hopefully you guys are remembering that if we are to graph an absolute value function, value starts with a V. Absolute value graphs are a V. So we're going to start with this warm-up, jog your memories on how to graph these, and then we'll dive into the square roots. So first off, each value, the number inside of our absolute value bars, that is what we call our horizontal shift. Horizontal shift. So this tells us how far left or right we need to go. And because of the subtraction sign here in our equation, the H value is always the opposite of what we think. The K value then is our vertical shift. And that is our up and down then. All right, and then A then was what we called our multiplier. And remember, if that multiplier, that A value was negative, that's where it would flip the whole thing upside down. So we'd have an upside down V. That was when our A value was negative. All right, so let's go ahead and graph this bad boy then. So we have y equals the absolute value of x minus 2 plus 5. So first thing I'm going to do is figure out my horizontal shift. So remember, it's the opposite of what I think. So this is telling me I have a horizontal shift to the right 2. And then my K value is telling me that I have a vertical shift up 5. So starting from the origin, I'm going to go right 2 and up 5. And I'm going to label that point with a V for vertex. I could have labeled it with an S for start. Doesn't really matter. And now I need to figure out what I haven't done anything with yet. So I took care of my horizontal shift. I took care of my vertical shift. But I haven't done anything with that A value, which is technically a 1. And I haven't done anything with the absolute value of x. So now what we are going to do is we're going to think of that input versus output idea. So I'm going to make a table. And in this case, because I can take the absolute value of any number really easily, because of that, I'm going to use my basic 5 for my inputs. So now when I plug in negative 2 into this equation here, the absolute value of negative 2 is just 2. When I plug in negative 1, so when I input negative 1 into my equation here, I'm going to end up with a positive 1 in return. Same thing, when I input a 0, I'm going to get a 0, etc., etc. So now, what the heck does this table tell us? So our inputs, our x values here, tell us left or right. So from the vertex, how far left or right am I going? And then your outputs, if we're thinking of like function notation, our outputs tell us up or down. So for example, this first one is telling me that I'm going left 2 because it's negative, and then up 2 because that's positive. So from my vertex, I need to go left 2, up 2. Same thing with this next one. This one, because it's negative, is telling me from my vertex, we're always starting at a vertex, I need to go left one and then up one. So from my vertex, left one, up one. Same thing, from my vertex, I need to go left 0 and up 0, so that's just at our vertex. That's already there. Here we need to go right 1 because our input is positive, and then up 1 because our output is positive as well. And then same idea with our 2, 2. And now if we go ahead and graph it, it's going to look something like this. So we are going to use the same sort of idea, this input-output idea in our shifts in order to graph square root functions. So I really encourage you guys, if you have a piece of paper, to do this along with me. If you got a dry erase marker and a table you can write on, even better. But we're going to graph, I believe it's 2 square root functions. I'm going to show you how to do it. So, just like our absolute value equation, square root functions have that general form as well. Notice they're almost identical to each other. The only difference is that we have absolute value bars versus a square root bar. Only difference. Okay? That each value is still our horizontal shift. So how far left or right we're going. And it's still the opposite of what we think. And that K value is still our vertical shift. So up or down. And we are expecting you to use this language and know this language. So you might want to make yourself a little familiar with it. Your A value, we're calling that your multiplier again. And just like before, when your A value is negative, we will see our square root function kind of flipped upside down, and we call that a reflection. So when A is negative, that is a reflection. It's kind of a mirror image over your x-axis. All right, so let's go ahead and graph this bad boy. So we have the square root of x minus 3 minus 5. And I apologize, when I printed this off, I didn't take the graph paper off before I printed it, so we will be okay. Just bear with me on that. All right, so exactly like we did before with the absolute value, I'm going to figure out my horizontal shift. So that is the one inside my root. And remember, it's the opposite of what we think. So this is telling me that I need to go to the right 3. I have a horizontal shift right 3. And then my K value is my vertical shift. So in this case, it's saying I have a vertical shift down 5. So my vertex point, my start point, whatever you want to call it, is going to be right 3. So 1, 2, 3, and down 5, which is that point right there. And again, I'm going to label that with a V. If you want to label it with an S for start, doesn't matter. All right, so now we need to figure out what the heck we haven't done anything with yet, just like what we did before. So I haven't done anything with that A value, which in this case is 1, so I'm not going to write it. And then we also haven't done anything with the square root of x. So now I'm going to make my table of my inputs and outputs just like what we did before, but this time I'm not going to use my basic 5. We're going to pause on the negatives for a second. We'll get to the negatives. But the reason I'm not going to use my basic 5 is because the square root of 2, if I input in 2 for x, I have no idea what that is off the top of my head. It's a nice long decimal, and I don't want to deal with decimals. I want to deal with nice numbers. So this time when I choose my inputs, I'm going to choose numbers that we can easily take the square root of. So for example, I'm going to choose 1, because if I input a 1 in for x, I'm going to get a 1 in return. My nice perfect square, my nice number that I can take my square root of, the next one is going to be 4. And now if I input a 4 in for my x, I'm going to get a 2 as my output, a 2 for my y value. And then the next number that I can take the square root of nicely is going to be 9. And when I input a 9 in for x, I'm going to get a 3 in return. Okay, so I'm going to pause on my table for a second. Let's go ahead and graph what we have right now. So again, this is saying that I need to go right 1 and up 1. So starting at my vertex, I need to go right 1, up 1. Next one, starting at my vertex, my input tells me I need to go right 4 and up 2. So vertex, right 4, up 2. And this one is obviously going to be off the graph. If I were to do it though, I would need to go right 9 and up 3. So for square roots, we would like to see at least 3 points if you can. Okay. Now, the reason I have paused on our table here, the reason I didn't include any negatives, if I were to input a -1 in for x, I get a I in return. And we know that we can't have i's, or we can have i's, we just can't graph them. We don't know how to. So, because of this fact, there's actually nothing on the left side of our vertex here. Because when we input negative numbers, we end up with imaginaries in return, and we can't graph those. So, this is actually the graph of a square root function. It's kind of like one arm. Okay? Couple quick things about this. This is obviously going to the right forever and ever. And as it's going to the right, it is gradually getting higher and higher and higher as well. So it's not going up by very much, but it is going up. So our domain, remember domain is our x values. Our domain, if we look at the smallest x value we have, that would be at +3. Which is, notice your h value, and we want the x values that are greater than 3. So our domain is going to be x is greater than or equal to, because it can be 3. And then my range, my y values, if we look at our y values, the lowest y value that I have is -5. And we want the y values that are greater than or equal to that, because remember, it's going on and up and over forever. So eventually, it's going really slow, but eventually it will get higher and higher and higher. So it will hit all of those values that are greater than -5. And there's your graph. Easy peasy lemon squeezy, right? All right, let's do one more. I'll do this one a little quicker. Notice in this one, I wrote it to the 1/2 power. But remember, 1/2 is the same thing as writing a square root. So if I wanted to rewrite this, I could rewrite it like this. They mean the same thing. All right, so let's find our vertex. So remember, h value, opposite of what we think. This is telling us that I need to go left 1. So horizontal shift left 1, and then I have a vertical shift down 3. So starting from my origin, I'm going to go left 1 and down 3, and I'm going to label that. All right, and now if we think about what we have not done anything with, I haven't done anything with my a value of -2, and I haven't done anything with the square root of x. And now, this multiplier, this 2, this is telling us that this function, compared to the last one we did, is going to kind of grow twice as fast. And it's also going to be flipped upside down. It's going to be a reflection. So it's going to kind of go down like this, which we'll see in a second. All right, So go ahead and make my table. I know because this is a square root function that I'm not going to have to worry about any negative numbers. So let's see, I'm going to go ahead and input a 1. So I can take the square root of 1 nicely. It's just 1. And then negative 2 times 1 is going to give me a negative 2. Next nice square root number I can take is 4 then. So if I input a 4 in for x, see, this is going to clean up till 2. And negative 2 times 2 is negative 4. Let's see, let's do one more. So square root of 9 is 3. 3 times negative 2 is going to give me a negative 6. All right. So again, from my vertex, this is telling me I need to go right 1 and down 2. Right 1, down 2. This one is telling me I need to go right 4 and down 4. And notice I always started at my vertex. And then last one, I need to go right 9 and down 6, which I believe puts me right there. So again, notice it's a reflection, it's flipped upside down, and it kind of grew twice as fast. So my graph is going to look something like this. And again, it's going on to the right forever, and it is going down little by little as well. So our domain then, this time we want all the values that are less than or equal to negative 3, because we have everything under that negative 3. Oh, crap. Man, that was my range. I blew that one, didn't I? All right, my y values, my highest y value I have is negative 3, and I want everything less than that. Sorry about that. My x values, though, my lowest x value I have is negative 1, and I want the ones that are greater, that are bigger than negative 1. So that will be my domain. All right. So there's how we graph cube root functions. You guys have an activity on Desmos to do. Those codes are on both Infinite Campus and Google Classroom. Please, if you have questions, either post them to our main stream page there on Google Classroom, or email either Mrs. Kinnaman or Mrs. Cadlick so that we can see those questions and get them answered right away. Have a great night, guys, and stay healthy.